So the strategy that I'm going to highlight is creating a word wall. And again, this orange link is to the OAME website lesson plan. So what is a word wall? Well, as relevant vocabulary is encountered, words without their definitions are written on index cards, and then they're displayed on a bulletin board or other clearly visible fixed space where they can remain in the same location. You could also have students record their own personal versions of the wall if you like. What words are relevant? Well, a word wall can include words that frequently recur in math problems. Action words such as analyze, compare, or calculate, or even words like nearest, approximately, or simplified. Or more obviously, a word wall can include terminology such as slope, rise, or run. It can also include symbols and even formulas or pictures. A word wall can be categorized according to students' needs. It changes continually, evolving throughout the year as students reorganize words, master some words, and learn more. The goal, of course, is continual relevance. A word wall is also integrated. In the lesson plan from the OAME, the word wall is suggested as an isolated activity, but that's not the intention of the wall. So ignore this part of the lesson plan because it's best integrated into the daily activities of the classroom. That way it doesn't become one more thing to do that you might never get to, but instead something that augments what is already happening in the classroom. So try a word wall for an entire chapter or more before evaluating its role and usefulness. Here is a sample or a visual of a word wall in a math classroom. This one has been divided into 3 subject areas, and you can see words listed there without their definitions. As you can see, it provides a visual reference for students. It helps improve their spelling. It promotes comprehension and word recognition, which is particularly important for some of the teaching techniques we will be introducing in the next section. It also leads easily to review and preview activities, such as 4 corners. Again, a link here to the OAME website. To play, you would first designate each corner of your classroom as A, B, C, or D. And then using words from the wall, you can create multiple choice questions to test students' knowledge. And by create, I mean make up off the top of your head or have students come up with the questions themselves. Here's an example targeting the word overhang in a problem from MathWorks 10, section 7.1 on the Pythagorean theorem. So the question in the diagram, quickly draw a diagram similar to this on your board. Which letter labels the overhang? Students select their answer, then move to the corresponding corner of the classroom. Teachers then have an immediate visual as to how many students understand this concept, and the results can lead you to scrap or keep existing word wall words. Another game that can be used for review and reinforcement I call head-to-head. Good times for this game are as soon as the bell rings to review words that students are currently learning, or at the end of a class to fill in a few minutes. Divide the class into 2 teams, and for each question, have 1 student from each team come up to the board. Use words from the word wall, again pulling them quickly down just off the top of your head to create quick questions, awarding a point to whichever team indicates the correct answer on the board. For example, ask the first pair to draw a right triangle. The second pair, label the hypotenuse as C. The third, to label the legs of the triangle as A and B. And the fourth, to write down the Pythagorean formula. Teaching techniques. In this section, we will discuss a few ideas. Here's an overview of each before I get into more detail. A reminder that the idea is that these skills are to be taught to the students so that they can learn to filter information for themselves. The first category is simplify, further divided into begin at the end, parse the language, and break it down. After this comes make it real, or what I like to call shift the onus. As teachers, we work hard. How about we do less so students can do more? Lastly, we have bring it together, which is a powerful combination of simplify and make it real, shamelessly borrowed from math teacher Dan Meyer. We begin with simplify. As we discuss this section, you may recognize many of these concepts as techniques that you employ to alter or scaffold the questions or lessons for your students. At a previous presentation, one teacher told me that in order to prepare for his classes, he essentially rewrites the textbook each day by paring it down to the bare minimum. Diagrams, units, questions, then retyping the final product. I thought, wow, what a lot of work. What a fantastically dedicated teacher. What a lot of work. But for those of us teaching students facing literacy challenges, this approach and others like it often seem a necessary evil. But what about approaching it from a different angle? The suggestion here is that we directly teach our students the techniques we use so that they can simplify the material for themselves. After all, this ability to identify the relevant information is a life skill important to all of our students, to all of us in this information age, and particularly students with low literacy levels. Teaching the students to simplify for themselves empowers them by developing their confidence and feelings of competence. Not to mention the fact that as teachers, we work hard. Boy, do we. So instead of taking the job on yourself, try guiding your students to do some of the work instead. Of course, as with much teaching and learning, it is often easier said than done, and it won't happen overnight. But take one step at a time, keep at it, and let us know how it goes. So, step one, begin at the end. In a complex or wordy problem, where do we find the question? Nearly always, it's at the end. Since students need to extract what is important from the blurb at the beginning of the question, direct them first to the end. First, ask students to determine, what are you being asked to do? Notice any action words like calculate or simplify. And this is when the regular interaction with the word wall should start to come into play. Next, parse the language. Highlight any units you see. Be on the lookout for abbreviations and numerals. What do these units mean? Well, look in the sentence and circle the related nouns, pronouns, and their reference. In other words, the noun to which the pronoun refers. Continue to work backwards, reading through whole sentences, but in reverse order. Ask yourself, do we know all we need to know? Are we searching for more information? Regardless of the answer, of course, it's still important to continue to the beginning of the question to determine if there are any missing pieces. Along the way, notice transition words or words that provide emphasis, what I call signal words, such as however, or importantly, or above all. Notice also other word wall words, chapter terms, other mathematical terms. Students can use the word wall as a visual reference as they're working through the problem, but the review of the words on the wall will hopefully have improved their word recognition as well. Then I suggest that students reread the question from the beginning to double check and see if there's any important information that was missed. Now break it down. Ask, what do you have, what do you need? Write it down, then draw a diagram if applicable, and solve. So let's look at an example from MathWorks 10, section 4.4 on making conversions. So here we have a problem, and it's a wordy one. So let's just try employing our simplify steps. So first of all, begin at the end. Let's look to the end, and there, yep, sure enough, there's our question. What is the lowest rated elevator that Jason should install? So what are we being asked for? A lowest rated elevator. Okay, so we'll have to fill in some pieces there. Next, we're going to parse the language. We're going to work backwards and scan for units. Well, here I see 1,000, 2,000, 3,000, 4,000, 5,000, or 6,000 pounds. Okay, there's some units. What are these ratings for? What are these? Well, reading backwards, they're ratings. They're weight ratings for the elevators. So now we have boundaries for our answer. We know it's going to be between 1,000 and 6,000 pounds. Keep working backwards. Now I notice 90 kilograms each here. What's 90 kilograms? Reading the sentence, I see that they are 90 kilograms each. What is the referent for they? Well, here it is again, they. And here we go. Okay, people. We've got people. People who are 90 kilograms each. So how many? Oh, okay, here we are. 2 strong people, 90 kilograms each. As I continue backwards, I notice 545 kilograms. What is the mass for? Well, a piano. So I've got 2 strong people moving a piano to figure out the rating for an elevator. Starting to make some sense. Are we missing any information? We don't seem to be, but we would still need to read through the remaining sentences to check, noticing any word wall words or signal words in the process. For the sake of time, I'll tell you that we are safe to move on to the next step, which is break it down. What do we have? What do we need? Well, we've got 1 piano and 2 people and their masses in kilograms, and we need an elevator rating between 1,000 and 6,000 pounds. In other words, we need the total weight in pounds. Let's eliminate the problem so we have some space to work on solving it. So first of all, draw a diagram if applicable. Here's our people, here's our piano, there's their masses. Add it up, and we get a total of 625 kilograms. Next, we can solve using proportional reasoning, which is perfect for unit conversions. This method, however, is covered in the textbooks, MathWorks books, once and once only in MathWorks 10, section 1.1 on proportional reasoning. I highlight this since many teachers have expressed regret for not focusing on this strategy further, since it can be applied to so much of the math throughout the rest of the textbook and in MathWorks 11 and 12 as well. It may be worth revisiting with your students. The principle of proportional reasoning is to set up proportions to compare equivalent units, then solve for the variable. And the method taught in the text is to solve using the fractions method, in other words, by creating common denominators. But my personal favorite is cross multiplication. Of course, this is based on the same principle as the fractions method, but the process has been simplified. I personally would argue that it's one of the most single useful tools I learned in my own high school math career. And for a proof that can be used to teach your students this technique, you can click on the orange link there. So then you would ask students to solve. Here solved using cross multiplication and evaluating the units, and then determine the final answer. The next technique is make it real. Fortunately, there are lots of great suggestions and support for interactive real-world activities and discussions ready and available in the MathWorks resources. Discussion, of course, to be continued in the webinar number 2. But here's a way to bring this idea into more conventional parts of the text, such as the lessons and word problems. This will make the material more accessible to all students by allowing them to experience it rather than just read it. Instead of using a lecture format to teach the lesson or having students open their textbook to the problem and leading them through it, try shifting the onus to them. Make the lessons concrete and relevant by using real-life materials, such as actual objects or videos and photos. Then guide students to discover the material themselves. Provide terminology only as it becomes relevant to the discussion. At the end, check the learning with the textbook to ensure that no pieces are missing and to summarize the information into notes. Once the lesson is established, give the students a real-world scenario and problem and lead them in a discussion to solve it. So here, for example, we have MathWorks 11 student resource page on the surface area of prisms. At the top, there's a lesson with some terminology, and at the bottom, there are some problems to solve. You could take this lesson a step further, making it real, by first giving students some examples and some non-examples of prisms. If you can bring in the actual object, so much the better. If not, do like I did and use Google Images. Then, guide students' observations. Ask them, what do you notice? What are the properties common to the first group, the other? As the discussion develops and the need presents itself, introduce terminology such as base and lateral face to the students. Then guide their conclusions. How would you define a prism? Let them brainstorm and agree upon a definition together. Continue the lesson by telling students, this is called rectangular prism. How do you think prisms are named? Of course, some of this material might be review, but as we know, students don't always recall the material that should be reviewed. At the end, compare the class's conclusions to the text information and summarize the information into notes. Then, after the lesson is established, present students with this likely familiar image and the scenario. You're an artist who would like to make your own version of this IKEA lantern with glass sides and a metal top and bottom, though they're going to be flat and not curved in the photo for simplicity's sake. So lead a discussion with your students. What would the finished lantern look like? Ask them to draw it. Continue. Does this meet our definition of a prism? What type of prism is this? Next, ask, what is the logical first step for planning the lantern? Well, I think we would need to draw the pieces. So we can introduce the idea of a net. Ask the class, now what do we need to know? Well, we need to know how big to make each of those pieces and how much glass we need. So in other words, we need to know the area. What do we need to calculate this? We need some measurements. So as your students become more experienced with this type of learning, they will become increasingly able to lead their own discussions and look for the missing pieces of information. Lastly, we have bring it together.